Hello friends, welcome to my new data structures and algorithms in Java tutorial series video. Friends, in this tutorial we will discuss how to search a given key in a binary search tree. Also in this tutorial we will see how we can search a given key in a binary search tree using recursion. So friend, let's suppose we are given a binary search tree and we want to search a particular value inside this binary search tree. So below you can see the algorithm to search a given key in a binary search tree. Also friends, the method which we are going to call is search method. And here inside this search we are again calling search method. Therefore in this algorithm we are basically using recursion. So friends, in order to keep the track of this recursion, we are basically maintaining a call stack, whose significance we will see while demonstrating the algorithm step by step. Friends, let's suppose we want to search a key 5 into this binary search tree. So in the first step we'll simply call this search method by providing it a root, which is the root of the binary search tree, and the key which we want to search. So friends, when the search method will start its execution, on the call stack it would look something like this. That there would be a search method on the call stack, and as we are passing the root which is nothing but 6 and the key which we want to search is 5. So here we are simply keeping the track of these values. Moving ahead. So friends, as we are searching a particular key using this recursion, we have to provide a base case so that we can come out of the recursion. So here the base case would be, we are simply checking in the if block that whether root is equal to null or root.data is equal to key or not. So currently you can see root is not equal to null. It is pointing to a node having data as 6. And we also know that root.data, which is value 6, is not equal to key, which is 5. Therefore the condition in if block comes out to be false. So friends, in our previous tutorial we actually discussed what is a binary search tree. So friends, the binary search tree is nothing but a binary tree which follows some properties. So the first property says that, let's suppose we are on a particular node, and if we traverse to its left subtree, we'll find the nodes having values lesser than the node value. So let's suppose we are on node 6. If we traverse to its left subtree, we are seeing the nodes having values 4, 2 and 5. So these all three values are lesser than 6. And similarly for any node, if we go to its right subtree, we will find the values greater than the node value. So let's suppose if we take an example of node 6. If we go to its right subtree, we are finding there are 3 nodes having values 8, 7 and 9. So all these 3 values are greater than 6. Also friends, these two properties should be true for each and every node of the binary search tree. And using these 3 properties, we are actually searching a particular key in the binary search tree. So here in the if block we are simply checking that whether value of key is less than root.data or not. So here you can see root.data is nothing but value 6 and the key which we are searching is 5. So by the binary search tree property, we know that 5 must be lying somewhere to the left subtree of node 6. So here the condition in if block comes out to be true. So friends, here we know that 5 must be lying to the left subtree of node 6. Therefore we are calling search method again by passing in the value as root.left and the key which we want to search. Also friends, when we call this search method, we are actually leaving this search method and we are again calling the search method. So therefore in order to keep the track of the previous search, we will store the line numbers. So it means that we are leaving this search method at line number 6 and we are again calling search by providing root dot left and the key which we want to search. So friends, this search method will be called again. And this time the root will become root dot left, which is nothing but 4. So here on the call stack there would be one more search method. So as we call this search method by passing root dot left, which was nothing but value 4. So root became 4. So here root will now point to 4. Moving ahead, we'll again check whether root is equal to null or not. So here you can see root is not equal to null because root is referring to a node having value as 4. We'll also check whether root dot data is equal to key or not. So here you can see root dot data, which has value 4, is not equal to key, which is 5. Therefore the condition in if block comes out to be false. And then we'll again check whether key is less than root dot data or not. So here you can see root dot data is 4 and the key which we are searching is 5. So therefore 5 is greater than 4. So the condition in if block comes out to be false. So the else part will be executed. So friends, as here key is greater than root dot data, we know that 5 must be lying somewhere to the right subtree of the node 4. So therefore in the else block, we'll simply call the search method again by passing in root dot right and the key which we want to search. And also friend, as we are leaving this search method, we have to keep the track of the previous search method. So first we'll store the line number. So it would look something like this, that we are leaving this search method at line number 8 and we are calling this search method again by passing root dot right as the new root and the key which we want to search. So it would look something like this. On the call stack there would be one more search method, and as we are calling it by root dot right, we know that root dot right is nothing but node having data as 5. So here root is 5. So root will now point to 5. Then we'll check whether root is equal to null. So here you can see root is pointing to node having data as 5. Therefore it's not equal to null. And we'll again check whether root dot data is equal to key or not. So here you can see key is nothing but 5 and root dot data is also 5. Therefore root dot data is equal to key. So the condition in if block comes out to be true. So friend, it means that we have found our key. So in the line number 3 we are simply returning the root, which is nothing but the key which we found. So this is the tree node which we actually found, and we are returning this tree node from this search method. So friends, after this line gets executed, this search method will be removed from the call stack and the execution point will go to its previous search method. And we also know that we had left the previous search method at line number 8. So we'll start our execution from that point. Also friends, when we had left this search method, we know that root was pointing to 4. Therefore now root will point to 4. And from the line number 8, we'll simply return whatever the value we got from this search method, which was nothing but a tree node having data as 5. So therefore this search method will be executed completely and it will be removed from the call stack, and the execution point will reach to this search method. And we know that we left this search method at line number 6. So we'll start our execution from line number 6. And also friends, when we had left this search method, that time root was pointing to 6. Therefore now root will point to 6. And finally we'll return what we actually got from the previous search, which was nothing but the tree node having data as 5. So we'll simply return 5. and this search method will remove from the call stack. So friends, this is how we actually search for a particular value in a binary search tree. Now let's suppose if we want to search one more value which is not in the binary search tree. So let's say we want to search a key having value as 10. So we know that 10 is not in the binary search tree. So let's see how this algorithm works. In the first step, we'll call the search method by passing in the root and the key which we want to search. So on the call stack, it would look something like this. That root is 6 and the key which we want to search is 10. Moving ahead, we check whether root is equal to null or not. So root is pointing to 6, therefore it's not equal to null. We'll also check whether root.data is equal to key or not. So here you can see root.data, which is 6, is not equal to 10. Therefore condition in if block comes out to be false. And then using the three properties of binary search tree, we will see whether 10 is lying into this binary search tree or not. So in the first step, we'll check whether key is less than root.data or not. So here you can see 10 is not less than 6. Therefore we know that 10 might lie somewhere to its right subtree. So the condition in if block comes out to be false and the else part will be executed. So here, as we know that 10 might lie somewhere to the right subtree of 6, therefore we again call search method by passing in root.right. So root is pointing to 6 and root.right is pointing to 8. And as we are leaving this search method, we'll keep the track of the line number, which is 8. And then we'll simply call the search method by passing in root.right and the key which we want to search. So on the call stack, there would be one more search method, and this time root will become 8. So root will point to 8. Moving ahead, we'll check whether root is equal to null or not. So root is not equal to null because it is pointing to a node having value as 8. We also check whether root.data is equal to key or not. So root.data is 8 and key which we want to search is 10. Therefore 8 is not equal to 10. So the condition in if block comes out to be false. We again check whether key is less than root.data or not. So root.data is 8 and the key which we want to search is 10. So 10 is not less than 8. Therefore we know that 10 might lie to the right subtree of 8. So the condition in if block comes out to be false and the else part will be executed. So here we'll again call the search method by passing in root.right. So here root is pointing to 8 and its right is 9. And as we are leaving this search method, we'll keep the track of the line number. So on the call stack, there would be a new search method, and this time root will become 9 because we are passing root.right. As root is pointing to 8, its right is pointing to 9. So here our new root will become 9. We'll again check whether root is equal to null. So here root is not equal to null because root is pointing to a node having value as 9. We will also check whether root.data is equal to key or not. So root.data is 9 and the key which we want to search is 10. Therefore root.data is not equal to key. So the condition in if block comes out to be false. We'll again check whether key is less than root.data or not. So here 10 is not less than 9. Therefore the condition in if block comes out to be false and the else part will be executed. Because we know that 10 must be lying somewhere to the right subtree of 9. So here you can see we are again calling search method and we are leaving this search method at line number 8. So we'll keep the track of the line number. and we'll call the search method by passing in root.write. So here you can see root is pointing to 9 and its write is pointing to null because there is no write child to node 9. So on the call stack there would be one more search method. So value of root will be null. So root will point to null. Moving ahead, we'll again check whether root is equal to null or not. So here you can see root is equal to null. Therefore condition in if block comes out to be true. So friends, condition in this if block is nothing but our base case, because after 9 there are no nodes into this binary search tree. Therefore by some way we need to exit this recursion. So friends, here we know that 10 is not lying into this binary search tree, and also root is pointing to null. Therefore in the if block we'll simply return root, which would be nothing but null. And as we are returning null, it signifies that key was not found into this binary search tree. So here this search method is executed completely. So it will be removed from the call stack and the execution point will reach to this search method. And we know that we had left this search method line number 8. So we'll start our execution from line number 8. And when we had left this search method, root was pointing to 9. So therefore root will point to 9. Also friends, what we had returned from his previous search, which was nothing but null, we'll simply return null from this search method. So it will be removed from the call stack and the execution point will reach to this search method, and we'll start our execution from line number 8. And when we had left this search method, root was pointing to 8. So now root will point to 8. And also friends, from this search method we'll simply return the null value. So this search method will be removed from the call stack, and then the execution point will reach to this search method, and we'll start our execution from line number 8. And when we had left this search method, root was pointing to 6. So now root will point to 6. And also friends, on this line we'll simply return the value which we got from its previous search, which was nothing but null. So this method will be removed from the call stack, and at last we'll simply return null, which would signify that value was not found into the binary search tree. So friends, in this tutorial we saw the demonstration of how to search a particular key into the binary search tree. Now let's go to Eclipse and see the working of this code.